Alright, how's everybody doing today? We are going to take a look at section 5.1, which is the Midsegment Theorem. Now, we're going to start it off with a little bit of a joke. Why didn't the quarter roll down the hill with the nickel? The answer coming soon. Now at the end, don't forget to make sure that over the weekend or at some point you make sure that you take your time and take the survey that's there located on your screen. You'll need to type in that web address, go to that spot, and fill out the information for that. Now let's go ahead and take a look at a midsegment. Just what is a midsegment? Well, I'm glad you asked. Here's what it is. A midsegment is the segment connecting the midpoints of two sides of a triangle. Now make sure you write that down in your notes. Now let's kind of draw a midsegment here in our picture. Now it says a segment connecting the midpoints of two sides of a triangle. So I'm going to pick this piece right here and I'm going to call that point D. And D is going to be the midpoint of side AB. Then I'm going to go over here to side BC and I'm going to make this one point E and I'm going to call that the midpoint of BC. Now the midsegment is going to be that segment that just connects those two dots, those two midpoints. Now as a result of being midpoints, a couple of things are true. This piece from A to D is going to be the same thing as this piece from D to B because D is the midpoint of side AB. Likewise, over on side BC, from B to E, this piece is going to be the same amount as from E to C. Now that's just one midsegment in our triangle. We actually could put a midpoint over here on side AC, and say we put a midpoint right there. So go ahead and do that, and we're going to call that midpoint F. Now if that's the middle of side AC, then that means from A to F, however long this one is, from F to C is going to be the same distance, that same length. So when you mark your diagram, you're going to always want to make sure that you mark it like this, and then we want to go ahead and we can draw in those two other midsegments as well. One right there and one right there. So we're going to have three midsegments for any given triangle. And when you see a midsegment, you're going to go ahead and mark your diagram accordingly because that's going to set up a whole bunch of information for us that you guys will play around with here very shortly. Now the midsegment theorem says two things. If we're given a midsegment, in this case midsegment is going to be DE, then two things are going to be a result directly because of this theorem. First thing is going to be that DE and AC are going to be parallel. Remember that symbol means parallel. So if I've got DE right here, this piece is going to be parallel to its side opposite it right there. So we're going to have that part right there. That's going to be one of the things that's true about the midsegment theorem. Now because of that, there's going to be several other conclusions that we're going to make because of those two lines being parallel. Now let's kind of think about this for a second. I'm going to draw this off to the side here. If you have two parallel lines cut by transversal, so this is kind of where point D is right here, and then this is kind of where A is right here on our triangle. So those two parts, what's true about the angles that are located right here and up in this spot? So basically where this angle is and where this angle is right there. What kind of angles are those called? Do you guys remember? Hopefully you do. Two parallel lines cut by a transversal, those angles in those locations are what are called corresponding angles. And corresponding angles we know are going to be congruent. Now there's two other corresponding angles. They're over here on the other side. This angle right here and this angle right here. Both of those are also going to be congruent because they're another pair of corresponding angles. Now with that said, we've got one other conclusion that we can make. Let's kind of take a look at it like this here for a second. If we have two parallel lines cut by a transversal, the angle that's right here and then another angle that's up in here in this spot, what's true about that pair of angles? What is their sum? Hopefully you know that their sum is 180, and the name given to those particular types of angles, again, it's going to kind of depend on the textbook, but do you guys remember what it is? Hopefully you do. It's given one or two names, either consecutive interior angles or same side interior angles. Depends on the textbook, your teacher, and maybe even the test that you guys are taking a look at. But they all mean the same thing. So now let's formalize what we just kind of talked about a little bit. Our corresponding angles, we'll list both of those pairs. We've got BDE and angle BAC. That's going to be one pair of corresponding angles. They're the ones with a 1 hash mark. And then I'm going to have angle DEB, and my other corresponding angle is going to be angle ACB. Now don't forget corresponding angles. You're going to remember that corresponding angles are congruent or equal. Now the consecutive interiors, we've got our two pairs of consecutive interiors, angles DAC and angle EDA. That's one of our pair of consecutive interiors. And our other pair of consecutive interiors are angles ACE and angle DEC. And remember, their sum is 180 degrees. All right, so those are going to be our other conclusions that we're going to get, and that's just from that first piece of the mid-segment theorem, DE being parallel to AC. Now let's take a look at the second piece of the mid-segment theorem that says DE is half of AC. So what I want to do now is just kind of play around with this idea here in a little bit. Say DE was 10. Well, half of AC, if DE is half of AC, then that means AC, well, you just have to double DE to get AC, and that would just be 20. Right, that's pretty straightforward. DE's 10 and AC's got to be 20. But now what if we had two different numbers? All right, say instead of those two, say we had DE was 5, then how much would AC be? Well, you're right, it would be 10. You just double that. But say we don't have that. Instead, say we're given this part first. Say we have DE is the part we're trying to figure out, but we're given that AC is, say, 24. How much would DE be? If AC is 24, then we've got DE being 12. Now, try one more here with some numbers. Say AC was 40. How much would DE be? Yeah, I mean, you guys got mad skills. That's right. 20. Bam. You got this, junks. Alright, so that's pretty cool. You got the mid-segment theorem down pretty solid now. But I want to kick in one other thing with this. Say we know that DE is 20, right? But we've got this whole thing, AC was 40. But then say we had that midpoint down right in here. And we're going to call that just point F, where that midpoint is. And if that whole length of AC was 40, how much is each piece from A to F and then F to C if F is the midpoint? Check that out, man. That's pretty cool. So that's going to be 20 for that piece and 20 on the other side. So if we were to do this, sometimes you'll see this a lot of times in your picture where you'll be given just a 20 up in there. You won't be given the 40, but you'll be told that F is the midpoint or that maybe DE is the mid-segment. And check that out, man. You got all three of those parts right here, and right here. All of those are the same. And that's going to be true for every other mid-segment on there. This piece, from F to E, what two pieces would that be the same as? Go ahead, hit pause, and mark it on your diagram right now. Which other two pieces FE would be the same as? How'd you do with that? Did you get AD and DB correctly marked? If you did, good for you, man. You got this stuff. Now, what about the DF part? So this piece right here would be the same thing as which other two pieces? By now, I think you got it. Yeah, that's pretty cool. You got that stuff. So check this out, man. I'm just going to throw in some numbers here, and we'll play around a little bit with each one of these. So say you knew that this piece right here was 25. What other pieces are 25? Bam, you got that. B to E is 25, and so is from D all the way to F. That part's 25. Now let's go ahead and put in one other number. So show me what you got. See how your skills are. Say this piece up here, I'm going to give you dB this time. Say this piece up here is 10. So what other pieces are going to be 10? Go ahead and get those marked on your picture as well. And then let's check it out. Bam, that's 10. And the AD part, bam, that's 10 also. Now this is something that's really cool. While we're on this, we might as well play around with this junks a little bit more. Because check this other thing out. What I want you to do is pay attention to each one of the small triangles. Now, one of the things I want to take a look at here too is the perimeter of the small triangle. Check that out. Each one of our small triangles is going to have the same perimeter. If I add up 10 and 25 and 20, I get a grand total of 55. So each one of those smaller triangles has a perimeter of 55. Now, if I add up the perimeter of the large triangle, triangle ABC, check that out. How much is that? Well, that's 110 when you get done adding everything up there. What's the relationship between the perimeter of the small triangle and the perimeter of the large triangle? Man, you guys got a lot of skills if you can figure this out. The perimeter of the small triangle, to go from the small triangle to the large triangle, you times that by 2. You just double that. Now, if we knew the large triangle's perimeter to go backwards, we would just do the opposite of multiplying by 2. We would take half of it to go backwards and find that. So that's how those two things are related, man. That's pretty cool. But then there's one other thing I want to throw in here too while we're at it. Look at each one of those small triangles on the inside. Check them out. Each one of them would be congruent by what theorem or postulate from the last chapter? Do you guys remember all that stuff? Yeah, I'm sure you do. We got side, side, side for each one of those because each side corresponds to another side for all 3 sides. So we would be able to use our side, side, side congruence theorem for that. That's pretty cool. Now, enough about this mid-segment theorem because, man, we got a lot of stuff out of just those 2 little things right there. That's pretty wild. All right, so let's go ahead and get on and take a look at an example here. Now, in this diagram, we've got UV and VW being mid-segment. So I'm going to start with UV right here. So UV is this spot, wham, right there, and that's going to be a mid-segment in this triangle. So that means from there to there, that's going to be the mid-segment to that piece. And we've got to find how much UV is and find out how much RS is. So UV, we're going to go ahead and get after first. So UV, when I go to find that, I want you guys to write this equation like this. Now, what was the relationship between UV, the smaller piece, and RT, the larger part of the mid-segment, the larger mid-segment? So we're going to have UV equals half of the larger mid-segment, which in this case is RT. Now all we got to do, we don't know what UV is, so we're just going to leave that as that. RT, we know that's 90 inches, so we're just going to substitute 90 in for that. Now, doing your arithmetic, you just end up with 45. Now we have units here. Our units are inches, so make sure that you add that unit on there. So 45 inches, and that's all we got. That's how we find UV. No big deal there. All right, hopefully you're able to follow that and move right along. Now the other piece we got to take a look at, we got this VW part, all right, as being a mid-segment. So VW is bam, right there. That part has a length, we're told, of 57 inches. We know how long that is. But we got to find out how long RS is. Now, there's 2 different ways you could kind of work with this depending on the way your brain thinks. So what I want you to do is write down an equation for this to solve and figure out how much RS is. All right, so go ahead and hit pause, and then when you come back, unpause it, see if you did it the right way. Now, how'd you do with that? Hopefully, you either came up with the equation on the left, VW equals 1/2 RS, and then solve that to get 114 inches for RS, or maybe you thought about just doubling from the beginning and doubling that smaller mid-segment, so then in that case you'd write down the one on the right. 2 times VW equals RS, and bam, you end up with 114 inches for RS. Either way is okay, but small technical detail. Do not forget to write down the inches on this because that's the unit that we're given to work with. Alright, so make sure you take care of that stuff. Now, here we go for example number 2. This one's going to be pretty straightforward. We're going to mark everything that we're given here to be congruent in our picture. In triangle ABC, we're given that AD is congruent to BD. So where's that? So that's right there, and that's right there. And then BF and FC. So BF, so that would get 2 hash marks, and FC gets 2 hash marks. And then AE and EC, so now we got 1, 2, 3 there, and 1, 2, 3 there. Now, we're being asked a whole bunch of things here. First thing we're asked is DE is parallel to which one? So DE is right here. All right, that's easy to see. That's parallel to BC right over there. So that's pretty straightforward. Now, the next one we've got is AB. So AB is all the way over here, and that's going to be parallel to this piece right here, this EF. So we've got those 2 pieces now. And then we've got our last part. DF is going to be congruent to which 2 parts? Now what we got to do is kind of take a look at where DF is located. And if we take a look at that, we see that DF is right in this spot. And that's going to be parallel to this part right here. Alright, so from that then we can figure out the 2 pieces that DF is going to be congruent to. And that's going to be the AE part and then the EC part. So those 3 pieces will be congruent to each other. But now, say we wanted to take a look at one of the other sides. Say we took a look at this piece AD. Now notice how that one has 1 hash mark there. So that means AD would be the same thing as DB and this other piece right here from EF or FE. But say we had DE. That would be the same thing as the BF and the FC part. So both of those, so you can mark your diagram like that for that piece. Alright, so that's all there is to that piece, and that's all we got to do for it. Now, one note about the order of the letters, the order doesn't matter. Like I wrote down BC, if you write down CB, we're talking about the same part. Just make sure your technical writing is good and make sure you include the segment symbol right above those two letters. Alright, now we've got one other piece to take a look at. Plane figures, placing a plane figure in a coordinate plane. Now, when we put a rectangle into the coordinate plane, it's going to be pretty straightforward. You're either going to lay it like the one on the left side, or you're going to put it like the one on the right side, because that's what's going to make it really easy for us to figure out how long each one of those sides are. So when we do that, okay, so we're going to be given our sides. Now this piece right here in that corner, you guys should know that that's the origin. So that would be 0, 0. Now as we go around to the right, we don't know how long that distance is, but generally we'll just call that A. We'll just start with the letter A, but we're not going up or down, so that would be A0. Now if we continue to go upwards, now I don't know how high we go, but we do go up a good bit amount, but we still go over A and up a certain amount. So A would be our first coordinate, and then we'd go up B for our second coordinate, because we don't know how high that is. Now what about this last coordinate over here on the left, right on the y-axis? Do you know what the coordinates would be? Hopefully you can look at that pattern and figure it out. Put down what you think it is, and then let's check and see if you're right. Did you have 0B? Good for you if you did. If not, just think about it like this. This other piece out here, AB, that coordinate for this endpoint right here, that's B high. Alright, so that has to be the same value because they're the same height. Now, 0 is because we don't go anywhere on the x-axis, so that would be our x coordinate. Again, we'll start here at the origin, 0, 0, and this time say I go up first. Okay, or we could have 0, and we'll call that B again if we wanted to go that way. And then over here we would have AB, where we'd have our two general points, and then over here we'd have A0. So it's just going to depend on how it's oriented, but that'll be real easy for you guys to count when you orient it that way on a picture, because that's all you got to be able to do is count. So these are just general formulas for this. Now let's take a look at our isosceles triangle. Now with the isosceles triangle, you have to remember a couple things about it. One, this side and this side. Do you guys remember what those are called? Hopefully you do. Those are called the legs. That's right, and your legs are both of those are the same. And then along the bottom, do you remember what that was called? Hopefully you do. That's called the base. So what we're going to do is orient that so that the base is somewhere on that x-axis. And we're going to go ahead and actually, we would place it right there on the x-axis, just like that. Now, with the legs being the same amount, all right, what I want to kind of do is play with this idea here. Say your base had a length of 6. Say the whole thing was 6. Well, halfway in between that, this midpoint right here, where that spot would be, well, that would just be halfway between that, so that would be 3. Does that idea make sense? All right, let's play with this again here for a second. All right, say the length of your base was 10. Then that means that midpoint, that would be 5. So we're going to kind of use that idea when we go ahead and write down what our coordinates would be for this one. Now, here again at our origin, we're always going to be at 0, 0. Now if we go over to the right side, okay, instead of going out 10 or for our length, then we're just going to call that generally point A. But then we don't go up or down, so that's just going to be 0. Now remember, halfway in between the legs, that's where the top is going to end up going. We're going to go that far, halfway in between. So that part right in here is going to be half of A. And then however far up we go on the y-axis, well, that would be our other coordinate. So we're just going to call that B. So half A would be the first coordinate, that'd be our x-coordinate, and then B would be our second coordinate for that tip top of the isosceles triangle. And do you remember what that spot's called? That top part? Yeah, hopefully you do. That's called your vertex. Okay, because remember that angle that's right up in there? that angle right in there, that's going to be your vertex angle. So just throwing a little bit of old vocabulary review in there. Alright, so hopefully you guys were able to pick up on that, and that's alright. We'll practice that to make sure that you get it down and everything, and we'll put some numbers in there, and you'll be fine and ready to roll with it. Now let's go ahead and take a look at our joke of the day. Okay, why didn't the quarter roll down the hill with the nickel? Yeah, that quarter's no fool. He didn't go down there because it had more sense. That's right. Now, when you're done, don't forget, make sure that you take your time, fill out the survey that's located there on your screen and also in your note packet for you guys that have me. Alright, thanks very much for watching. Peace out. Have a great day.